KLD of P x Qx is equal to Px it's the probability of x, and it's the logarithm of ratio between Px and Pq. As you can see here, the KLD of P and Q is not equal to KLD of Q and P.
Excuse me. KLD is the algorithm for finding the
KLD
similarity.
is the measure for similarity between two distributions. First distribution is PQ, and second one is the Q, P and Q. For example, if you can see P and Q in this picture, and the KLD of P and Q is the right picture, and P and KLD of PQ equal to 0 if P equal to Q. But as you can see here, is not symmetry, it's asymmetry. And in our projection, we use PQ. For example, FIX, QIX as we use FI, QI. FI is prior and QI is observation. If we use in this direction, I mean, first is prior and after that is observation, the optimization of the graph is the local, and use the local optimization on the graph, we can't say it's the global. But if we change these two parts, for example, first one be Q and after that be F, the local optimization is equal to global optimization. The proof of this is in the references, and if you are interested to see it, you can review the proof. And last thing I want to say is here we have in the bottom we have some PX, and in one PX is blue one, and some QX is red, yellow and green, and you can see what is the value of KLD that show if more different between KLD and more different between Q and P, the value of KLD is bigger. And for finding the best projection, we try to minimize this value. The minimum value of this shows the most similarity, or find the best approximation. It's a reference. I put a code, but it's not question, it's for see what is the KLD. I don't find good question for EP, but I try it in the week, the next week to find a question and upload in the wiki. But I put a link in the wiki. You can download a MATLAB file and see what is the KLD and try to prepare a question and upload a link about the image. If you have a question.
So they actually minimize that? I mean, that's how they implement that, like in wiki. They actually try to minimize the
KLD.
conversions?
Yes. Yeah, try to minimize the KLD in the first part.
So how did they minimize that?
It's iterative.
Iterative for-
Yes, it's iterative in each. For example, in the whole graph, we try to iterate within each node to find the minimum of these, and it's faster than ordinary because in ordinary we have multiple Gaussian, and if we try to find the best multiple match Gaussian, it's very time consuming, and if try to approximate by one approximation, as you see in the first pictures, if try to approximate some mixture Gaussian with one Gaussian, the error is very high, and if we try to use the multiple Gaussian by multiple Gaussian, is very time consuming and it's not linear. For example, if we have a 2, the time of finding the best match is more than 2 times, and for 3 is more and more. Because of this, we can approximate in one, but with the moments similar to observation moments. Okay, so excuse me. The reference here is two reference. The first one is the paper of Tom Minka. In this website has some quick reference in 5-page and less than this, and it's very helpful to understand and find which formula is good and which not. And another one is in infer.net, but I don't have enough time to work with this, but it's engine to work with EP